Welcome to AQA A-Level Physics, Measurements and Their Errors, Limitations of Physical Measurements, Part 1. Now, sometimes in our experiments we don't always get the true value. We sometimes have what we call error. Now there's two main types of error. There's random error and there's systematic error. Random error is caused by unknown or unpredictable changes in the environment. An example would be titrations. We don't always know the exact conditions of the instruments and the liquids involved. Another example is heat loss. The greater the difference in heat, the more heat will be lost. And because the air temperature fluctuates, different amounts of heat will always be lost, and we don't always know or can predict it. The main way we get rid of random error in our results is by doing repeats. While one measurement may not be accurate, many averaged out probably will be. Now, systematic errors are caused by faulty or misused methods or instruments. So whether that's a broken instrument or a method that won't work, or a method that you followed wrong, or an instrument you have not correctly used. An example would be a zero error. A zero error is when you have not zeroed an instrument correctly. For example, a balance should read 0 grams with nothing on it. If it read 0.5 grams and you continued with your experiment, you would have a zero error with an offset of 0.5 grams. The main way we reduce the amount of systematic error is by changing method and changing instruments. Now there's 5 terms you have to be able to use and define about results and experiments. The first is accuracy. Accuracy refers to how close to the true value a result is. The second is precision. This is how close results are to each other. Those two refer to results of measurements. The next is repeatable. You may have come across this term before. Your experiment is repeatable if you get similar results. For example, if you repeat your experiment a few times to make an average and you get similar results each time, your experiment is repeatable. Your experiment is reproducible if others get similar results. For example, in a week's time, if another group in a different area tried your experiment and got similar results, your experiment is reproducible. This is ideally what we want our experiments to be. And the last is resolution. And this is instrument accuracy. For example, a normal 30cm ruler with 1mm indents will have a resolution of 1mm because that's the closest to the true value it can measure. Now we can look at precision and accuracy as targets. I'm going to draw that a bit bigger. There's not much space now. There we go. With a dot in the middle being the true value. Accurate data will look like this. Not necessarily close together or on true value, but the average is the true value. So that would be accurate data. Precise data would look like this. There's not necessarily close to the true value. The average isn't the true value. but the results are close together. We normally want our results to be both accurate and precise. We can link these terms and errors together with a visualization. Here, that means random error, and this means systematic error. L means low, so these black dots would be the results if there was a low random and a low systematic error. However, if we had a low random error and a high systematic error, the results might look like this, with the origin being the true value. If we had a high random error and a low systematic error, we might get results that look like this. And if we had bad results with a high random and high systematic, the results will be down here. Now we can look at these two and link it to this visualization. As you can see, the black and the blue are highly precise, and the thing that remains constant is the random error. That's because the lower the random error, the more precise your data will be. And the opposite is true for accuracy. The green and the black are most accurate. The thing that has remained constant is the systematic error, because the lower the systematic error, the more accurate your data will be. And that concludes today's video. Hope you learned something. Goodbye.